So next up is Ahir Reddy, who's actually one of the early employees at Databricks, and he'll be talking about one of the things that Databricks have been doing that they're pushing into the open source Spark project. So please go ahead.
Hi everyone. Thanks Ali for introducing me. So I'm a software engineer at Databricks, and I've been working on SIMR, or as you can see, Spark in MapReduce. So to give you an overview, let's see, one second. So what is SIMR? SIMR is very simply a Hadoop MapReduce job that runs arbitrary jars that you provide it. What it does is it wraps normal Spark jars and deploys them on clusters where you can't necessarily deploy Spark natively, like on Hadoop 1x, where you don't have yarn. So Hadoop MapReduce, in essence, acts as a resource manager that allocates. Thanks. So Hadoop MapReduce acts as a resource manager that allocates mapper slots to SIMR. So we'll go into this a bit more. And one of the big things is there's very little change required for existing jobs, existing Spark jobs. So using SIMR, running a job is as simple as providing your job jar, your main class that will run the Spark job, and providing this special parameter, a Spark URL. I'm sorry if you can't really read that. You simply give it this specialized parameter and then your normal parameter list for the job. The standard out and standard error of your job will be redirected to your console, and everything will be saved as log files on the HDFS, including output of worker nodes. You can specify this out directory yourself, otherwise it'll automatically be generated for you. And on top of this, SIMR is also packaged with a Spark shell that you can just run with this pretty short command. And we wrote it as a job jar, just like anything else. So restructuring a job is pretty straightforward. We basically need to do this to facilitate setting up and tearing down the job properly on top of MapReduce. So the primary change is your job needs to take the driver URL as a command line argument. A lot of jobs probably already do this. So you pass the URL, and that URL that's taken in has to be given to your Spark context constructor, like so. And from there, you can use the Spark context like any other. Right, it's restating what I've said. Right. And SIMR, so this specialized argument will be used by SIMR down the line and will be replaced with the actual driver URL. And as far as cleanup, just make sure that before terminating, you call stop on the Spark context. And that's basically it. Those are all the changes you'll have to make to your existing jobs. So we talked a little bit about how to use SIMR, but we'll dive into how it actually works. Just to give you an overview, SIMR deploys a MapReduce job. It performs leader election that determines the main Spark driver and the worker nodes. It establishes a relay server that sends the standard error and standard out to your console and to the HDFS. The relay server starts up the Spark driver, workers connect to this driver, and the relay client is your window into all this action. And then we'll go over job execution and cleanup. So deploying SIMR, SIMR launches a MapReduce job that contains only mappers. It ships the jar you specify to each of the mappers, and it also ensures that Scala and Spark are shipped to each of the mappers, so you won't run into any issues. A little bit more technical here, the class path on the mappers is structured in a way that all the jars we ship and your job jar appear first in the class path, and all logs and temporary files are in HDFS. So SIMR performs leader election first off. Once the mapper is all running and everything is in place, that does the election via directories in HDFS. The winner is elected to be the relay server, and everyone else is a worker that will eventually run a Spark executor. And here, we'll jump into the relay server. It's responsible for executing the job jar that you provide it. It sends its own address via HDFS to the relay client, and subsequently communicates with the client via RPCs. And it also does the job of providing your job jar with the actual Spark driver URL. It directs standard in from the relay client to the main class. So this means you can, run commands, send data directly from your console to your job, or in our case, type into the Spark shell directly from your command line. And it sends the standard out and standard error to the HDFS and back to the client. And it'll, obviously execute the main class of the job. So upon execution of your class, the SIMR path will make its way to the Spark context that we talked about earlier. This will launch the new backend scheduler that we wrote for SIMR that lives inside of Spark. This will write its own URL to the HDFS so that later executors are able to connect and perform whatever tasks they need to do. The backend then waits for executors to connect before the job can proceed. So this is where we get to workers. The unelected mappers act as the worker nodes. Worker nodes poll the HDFS for the driver URL that was written previously by the backend scheduler. These workers invoke, then start Spark executors that connect to the driver, and your job should proceed from there. So the relay client is invoked in your console. Similar to the worker map task, it polls the HDFS for its own URL, the relay URL, and connects to the server upon finding it. So again, it can send standard in and receive standard out and standard error from your jobs. So from here, your job should execute normally. Spark executors will connect to the driver, and your job will proceed just like any other Spark job. At the end of the job, the reason we need to call stop on the Spark context is so that the executors can properly terminate and clean up inside of MapReduce itself. And upon receiving a termination message, each executor will end its own map task, as will the driver. And once everything is done, files on the HDFS will be cleaned up. And that does it for SIMR.
Okay, so questions. I have the first question actually. So this allows you basically to run Spark on any Hadoop MapReduce cluster.
Yeah. So.
My question is, what are the requirements on that cluster? What do you require? What needs to be installed on that Hadoop MapReduce cluster for you to be able to run these jobs with SIMR?
Got it. So we have a couple of Hadoop. So essentially, your regular Hadoop cluster, you need to have HDFS, Java and Java 1.6, and Hadoop cluster with MapReduce, and you should be good to go from there. And for the most part, it should work straight out of the box. We're going to provide a number of configurations so that things should just work with those basic requirements.
Other questions? Yeah.
So my analogy may be completely off here, but Apache Uzi, which is a workflow engine, does something similar with its workflows, where it will launch a Hive workflow and it will ship the Hive jars with it, and does something similar with Pig, where it will ship the Pig jars in a MapReduce workflow out to the cluster. Have you possibly considered integration with Uzi and somehow contributing that or collaborating this with Uzi to see if a a Spark action can be added there that will do something very similar to what this is sounding like?
That isn't actually something we've really considered, but I think it's definitely something worth looking into. So the reason, one of the reasons we chose this approach is it's sort of a very small code base. It's a very simple wrapper over Spark jobs, but I think integration with Uzi makes sense. It's definitely something we probably look into now.
I think I heard this morning when SIMR was introduced that it's not in production or it's not meant for production. Can you comment on that? I mean, is there any reason? From what you've said here, it looks like it's ready to go.
So we're planning on, so SIMR is supposed to be used in conjunction with 081. So I think that's what was meant this morning. And sort of on I suppose it's not something that you're meant to have a long-standing SIMR cluster. It's something that will run sort of job at a time. So I think that might be what was meant this morning. But yeah, it's primarily that it's 081 focused.
Yeah, and I think 081 will be out very soon. And we're talking weeks. So. Any other questions? Okay, let's thank the speaker again.